A polynomial expression is shown below. 7x to the power of 2, y, minus 5x plus 8y to the power of 2, minus 3x to the power of 2, y, plus 2x, minus 6y to the power of 2. Which expression is equivalent to the polynomial expression? Well, we are subtracting two different polynomials, so it's important to find our like terms. We have our like terms here of the x squared y's. Like terms don't have to have the same leading coefficient, but they have to have the same variables with the same powers or exponents. So both of these in green have x and y's, and the x's are to the power of 2's, with the y's being to the power of 1's. What are we doing with the two of these? The sign in the middle tells us we are subtracting. When we add and subtract polynomial expressions, it does not change our exponents, just the leading coefficients. So we got 7 minus 3 is going to give me a 4, variables staying the same, x to the power of 2, y. Then the next like term here, in red, are the ones with x's and just an x. Specifically, x to the power of 1's. In red on the left, we have the negative 5. In red on the right, we got the 2x. The minus sign in the middle tells us what we're doing with those two. And we have negative 5x minus 2x. That gives me a negative 7x. Once again, not changing the little numbers, the exponents, just the leading coefficients. Then we have the last part here. We have the y squareds, or y to the power of 2's. Both parts have y to the power of 2. We have to be slightly careful here because I have 8y to the power of 2 minus a negative 6y to the power of 2. So minus a negative becomes plus, and we get 8 plus 6, which is 14y to the power of 2, not changing exponents. I look at the multiple choice options, which one this matches, and it is going to match this one here, part B. It may also be beneficial, since you do not have colors available like I do, to draw lines and things underneath like this. This was the like terms here, the ones I'm underlining. Then I could do the waves for the x's. And then the last part, we could just do this little wavy thing here. And another method we could choose is actually making it in a different format. So we could rewrite the problem like this. 7x to the power of 2y minus 5x plus 8y to the power of 2. And underneath it, we can put the other polynomial expression aligned with its like term. So here, I would put the 3x to the power of 2y plus the 2x minus the 6y to the power of 2. And what are we doing with them? We are subtracting, subtracting, subtracting. And it would give us our same answer here. When I subtract the 7 and the 3, I'd still get the 4, x squared y, the negative 5x minus 2x, the negative or minus 7x, and the final part, the 8y squared minus negative 6y squared. This makes it easier to see the minus a minus, and that becomes plus 14y squared. And that's our solution when we write the expression in simplest form.